Okay, welcome back. Now we have an enemy controller, an enemy blackboard, and an enemy behavior tree, and we're ready to start using these. Now we're going to start off simple. We'd like to create a position in the world that our enemy can move to. And in order to choose that location, we're going to add a variable to the enemy class. Let's go back into Visual Studio, and here is enemy.h. I'm going to add an f vector. Now I'm going to call this f vector patrol point, and this will be a f vector that the enemy can move to. Now I'm going to give this a u property. I want to be able to edit this anywhere, so I'm going to add edit anywhere, and for the category, I'm going to give this behavior tree. Now, I need the meta specifier allow private access equals true, but I'm going to add another meta specifier inside of this. So here, just inside of the parentheses for the meta specifier, we're going to add another meta specifier, and this one is going to be make edit widget. And we're going to set make edit widget equal to true. Now what this does is this will give our f vector an edit widget in the world, so we can set this patrol point vector using the transform widgets, such as translation and rotation and so on. Now let's give this a comment and say point for the enemy to move to. Now as soon as you give an f vector a make edit widget meta specifier, then this will suddenly become a local vector. It will be a vector that's local to the enemy and not a world space vector. We'll see exactly what I mean if we compile this and take a look in the editor. So let's go ahead and compile our code. So we've compiled, and if we go back into the editor, here is our enemy. If we select the enemy, and in the details panel, search for behavior tree, we'll see the patrol point here. The first thing I want you to notice, the patrol point has values of 0, 0, 0 for X, Y, and Z. But our enemy here does not have a location of 0, 0, 0. Now we can select the patrol point on the enemy and move it out, and you'll see that the patrol point coordinates change. But this is a local position relative to the enemy's location. So this is not a world space vector. It's relative to the enemy. So if we wanted to use this as a location for the enemy to move to it, we need to figure out how to transform this into world space. Here's how we're going to do that. Here in the enemy class, we're going to go into enemy.cpp, and we're going to transform this vector in begin play. Now, in order to transform this vector from local space to world space, we're going to make use of a Kismet Math Library function, so we need to include Kismet Math Library. Now, for Kismet Math Library, we need to include kismet/kismetmathlibrary.h. So let's go ahead and transform this vector. Here in begin play, I'm going to create a new f vector called world patrol point. Now we can set this equal to the result of u Kismet Math Library transform location. Transform location is a function that will return an f vector, and that f vector is going to be a transformed version of a vector that we pass in. Transform location requires a f transform and a vector. Now the f transform we can pass in can be the transform of our enemy, and we can get that with get actor transform. Get actor transform returns an f transform of the actor. Next, we're going to pass in the vector we want to transform. That's going to be our patrol point vector. Now, I'll go ahead and put these input parameters on their own lines so we can read this. Now, world patrol point is going to receive the f vector returned by transform location. And for transform location, when we're passing in the enemy's transform location will transform patrol point using the enemy's transform, resulting in an f vector converted from local space to world space. We can prove this by drawing a debug sphere. If we want to draw a debug sphere, we can include here at the top, draw debug helpers. Draw debug helpers.h will give us a draw debug sphere function. So let's go ahead and draw a debug sphere. So draw debug sphere is going to take some inputs. The first is a uWorld, and we're going to use getWorld for that. Next, we need an F vector for the center of the sphere, and we're going to use this world patrol point. Next is the radius for the sphere. I'm going to simply use 25.f. Next, we need the number of segments for the sphere. We can use 12 for this. And next, we need an F color. I'm going to use red. And it's asking if we want persistent lines. I'm going to use true, and the rest of the inputs are optional. So that's all I'm going to pass in. So we're drawing a debug sphere at the world patrol point. Let's compile this and see where the sphere gets drawn. All right, so we've compiled. Let's go back into the editor, and we've got our patrol point here, and I've moved it out and down just a bit. Let's go ahead and hit play, and we'll see that we've got our sphere in the world location of that patrol point. So even though the patrol point itself is in local space relative to the enemy, we are calling draw debug sphere, which takes a world position, and it's actually showing up in the position that we chose for the patrol point here in the world. Okay, so now we have a location that we'd like our enemy to move to. In the next video, we're going to use this patrol point and have our enemy move to it using our behavior tree. I'll see you in the next video.